Alright, time for another draftphysics.com, debatephysics.com, also video presentation, and unsymmetrical hair. Okay, well, there's physics to that also. But anyway, PUSHaverse. So I'm just going to go through some of the history of physics real quick, and then we're probably going to talk about nuclear fusion. Okay. And whether or not that's a practical way to make energy, that is pushing things together, because that sounds like work, right? Yeah, it sounds like work. It doesn't sound like the kind of thing you're going to win doing, pushing stuff together. You're going to win letting it fly apart. And so the nuclear bomb, that's been proven, okay? Fusion, yeah, that hasn't been proven yet. Anyway, their theory regarding how the sun works, I would argue, is bad theory. All right, so the idea is that, look, push, easy to understand. Something bangs into something else, push. Okay, pull. No, it just there's no elemental pull. Just without magic, there's no elemental pull. All right, without an ether, without some kind of something extra, there's no elemental pull possible. And so, yeah, it seems like physics should have said that a couple of thousand years ago. The idea that push is easy to understand and pull is impossible to understand. Now we're to the speed of force. Okay, so the idea that we call it the speed of light, but in the years that have followed, okay, the first use of the term, it's been understood that magnetism and these other forces like gravity are also made of this speed thing. They have the same progression in terms of how the force imposes itself. So it really should be called the speed of force to really understand that light and gravity and magnetism, they're just forces. They're just something that is going the speed of light, very discrete stuff, invisible stuff, non-material stuff, you could argue, in the sense that, yes, it carries momentum, but it's not material in the sense that it's not like an atom, the stuff the atom is made out of, the matter bits. Okay. So, yeah, it's just, really, it's just matter against force, and that's all that's in the universe, and that's all that's interacting, but they won't say that. So the misdirection sort of started with wave particle, and that was, again, Newton against Huygens. In terms of Huygens had the wave theory, Newton had the particle theory, and physics chose wrong. In my opinion, the particle theory was correct, and the wave theory was silly. Because things don't do this going through space. They don't do any of that crap. Anyway, and the idea that a particle theory can explain waves in the sense that particles can create something that can look like over a period of time. If I just randomly shoot bullets, it'll be a wave of bullets at the period at which the bullets are coming out of the gun. And it can look like a wave, but the bullets aren't tied to each other. There's no wave function. It's just the appearance. So particles can look like a wave. A wave cannot look like a particle. So again, bad choice. All right, so momentum versus mv squared kinetic energy nonsense. So it's again Newton against Huygens, really. And Leibniz, the thief, just kind of stole Huygens' argument and made it for him. So, if you really, that is the actual history. Huygens said it first, and Leibniz just said it louder. But it's a clear distinction between these two ideas of what energy is. Momentum works, I would argue, in every single circumstance. It'll never fail you. I will argue or state that I believe the lunar module landed on the moon calculating thrust based on momentum, not kinetic energy. The two do have different answers to the simple question, how long do I leave the thing on? The two theories tell you to leave it on a different amount of time. So you will not succeed with both. One will land you safely, one will crash you horribly. And that's just a fact, and I think it's already been proven, and NASA just won't provide us with the answer. We can't solicit the answer from NASA regarding what exactly was in the computer and what the calculation actually was. But anyway, there's other ways to prove it's nonsense. Just watch a lever, watch a balance in action, crash cars, lots of ways to find the truth. And physics just doesn't really want to know the right answer because it has the wrong answer, and it wants to think, well, we're gonna go with that. Anyway, so nonsense. All right. So, what did I write here? Fundamental things and functions. So yeah, the universe is just made out of things and their functions, and there's, I would argue, these really simple functions. Where everything is just sitting in this field. The matter is just electrons and protons. There's no other matter. Electrons and protons are just sitting in this field of energy, okay, and the energy is pushing them about by rules. And the rules have the simple little catch where, you know, the simple process, okay, is, yeah, if I hit a piece of matter, okay, with a force bit of the same type, electron force hits electron, it's going to move it. And if the electron's already moving in this direction, that is, already has force stuck to it, then it's going to move a little faster. So basically it just collects force in one of the two dimensions. It can't go both ways, forward and back at the same time. So it can only go forward or not move at all or go backward, but it can't do both at the same time, any one of those. All right, and the simple argument is if the matter bit's already moving this way because it's collected force and a force bit hits it, it reflects, and one of the pieces of force reflects. So it diminishes it decelerates it by excreting a bit of pushing force from one side, and it excretes pushing force in the other direction. So the universe gets back what it put in. And the only catch, the one that causes so much of the interesting stuff, is that if an opposite force, that is an electron force, hits a proton force, or a proton, or a proton force hits an electron, it's changed. So the force goes in and it just pops out the same color as the matter. That is, it's converted. And that little trick, is huge in terms of creating the functions of the universe. Creating charge, which is the big one. Okay, so I do have the simulation video. I'll post a link below in the description to the video showing the simulation, explaining these simple rules. And it works. It shows you what charges would do if they were made out of styrofoam, and it shows you what charges would do if you imagine them as electrons and protons. It demonstrates, it models the function quite precisely, actually. All right, so magnetism and light are just two forms of this force stuff. So the fact is, every time an electron moves into the field, you could understand it's pushing on it. It's compressing it. So yes, that's how sound works. Sound comes out, it's pushing on the air molecules, adding extra pressure. So it's just saying we had atoms, we had 100 atoms in this much space, and now we have 100 atoms in this much space. So it pushes a signal of compression, okay, in the direction. And the same is true for water, except the trick is it's not as compressible. But the fact is it is compressible. So they say it's a non-compressible substance, and yet you can prove that it's compressible because you could take a jar down to the bottom of the ocean, you know, just fill it up with water, seal it up, and then take it to the surface, and it you know, in all likelihood might explode. Because the water has been compressed, and the compression will stay in that water until you get to the surface and you open it, and so it really is a compressible fluid. It's just that it's very hard to, you need a lot of pressure to compress it, and that's the only real distinction. And so you can send higher frequency sounds through the water, blah 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 blah, Well, I guess it's high, yeah, high frequency pulses. Okay, he said sonar, something like that. Anyway, beep, beep, beep stuff. Bing, 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 that kind of crap. And so it's the same kind of thing. You're just changing a hunk of the medium, and that hunk of change is just moving through the water with momentum. Okay, so it all has momentum. The force carries momentum. The light has momentum. The magnetism has momentum. Everything's carrying momentum. So light is just this stuff at a frequency. And the thing to understand, light is just doing this. That's blue light, and this would be red light. Not complicated. And it does have a polarization, but I won't bother drawing that here. And magnetism would be the trick, is the magnetism is being sent by a surface that's magnetized, which means it has an arrangement of electrons and protons on its surface, and there can be two types of arrangement, where the protons are more visible and where the electrons are more visible. So you can have two different ways of seeing the object, and it's radiating a different pattern depending on which way those atoms are arranged, and that's what magnetism is. It's just a difference in the pattern of the force being pushed against everything. So everything's just reflecting what's hitting it. Okay, really not complicated. All right, so then we move on to Newton once again with the bucket experiment, just to get rid of this relativity crap. So the fact is, the universe is a real thing, okay, and it has real positions in space. These are absolute positions. They're really not going to change. I could stand here literally for 1 trillion years if the sun didn't blow up and the earth didn't do all the other crap, and the distance between these two things would be the same. It's not going to change. All right, and places in space are real places, and yes, we're always on the move, so we're always changing our location, but our relative positions are staying relatively the same. In the bucket experiment, Newton did pretty much prove the point, that you spin the bucket, certain things happen, and it would be ridiculous to say that somehow the universe knew you were spinning a bucket and it created more gravity. It can't do that. The universe can't do that. It's a pretty decisive, if you really think about it, experiment. The fact is, Newton put it in the very beginning of his book because apparently there were a lot of whack jobs back then who were talking this relativity crap, and Newton felt the need to make a pretty hard point that it really is an absolute physical universe, three-dimensional universe, and there are no fourth dimensions, and time is just a function. You can't break that either. You can't go to time as if it's a place. It's not a place, okay? It's just a function, and it only exists because light has a finite speed. If light was infinitely fast or instantaneous, if the force could move instantaneously, then there wouldn't be any conversation because there would be no events that didn't already happen. It would already be over the moment it started. Anyway. So now we get to fusion. All right, and I bought into all the crap they've been saying for years about what's happening with the sun. Like somehow the sun is hot because it's converting hydrogen. Okay, and hydrogen are big atoms, right? That's why they're very buoyant. It's because they're big. Okay, their structure when they're together is very large. Okay, with very little mass in it. All right, so they take up space and they don't have any mass, so that's why they float, so to speak, to the surface. What the sun is really doing is it's compressing, okay, that hydrogen into neutrons. So it's just basically saying we're going to take the electrons and protons that are fairly far apart and we're going to push them very, very close together. And so I guess I could illustrate that in some sense. So it's taking, something that looks like this, and it's converting it into something that looks like this in the center of the sun, into little tiny amounts of space. So it's probably even more dramatic than that in terms of the size reduction, and in creating the first dipole, the neutron. Okay, it's not neutral. It's just that it has both poles. Okay, it's neutral because from a distance this will look purple. Well, it will look whatever green and red is, brown. So the idea is that the sun is radiating all of this energy, and they tell us that it's because the sun is converting hydrogen into helium. But the truth is it's radiating all that energy just because it's hot. It's under the same pressure the center of the Earth is under, and Jupiter and Saturn, and you can take their temperatures, and the fact is the sun is, logically hotter than Jupiter, and Jupiter's hotter than the Earth, and the Earth is hotter, okay, in its core than Mercury, 3 times as hot, even though Mercury is really close to the sun. Because yes, the core temperature is being dictated by the pressure being created by gravity. So it's gravity, okay, that's causing the sun to emit energy. It is not the fact that it's synthesizing hydrogen into helium. That doesn't have anything to do with it. It'd be hot no matter what it was made out of. It could be made out of hydrogen, could be made out of, it doesn't matter. Jupiter's made out of all kinds of stuff. The Earth is clearly made out of all kinds of stuff, okay, the least of which it's hydrogen, right? I think there's a lot more aluminum and iron than there is hydrogen. So why are we pretending it only gets hot if it's made out of hydrogen? No, it gets really hot if it's made out of anything. It doesn't matter what the matter is made out of. It just matters that it exists, and it's going to keep pushing towards the center of the planet, which is going to create a bunch of this way and this way. And the this way and the this way can't cancel. Okay, they can't just crash into each other. Nothing happens. No, it's a constant tug of war, a constant oscillation, a constant motion. That's the heat. So the sun is producing the amount of heat you would expect if just gravity was producing it. It's exactly as hot as it should be. It's doing exactly what it should be if it was any other planet. It doesn't need to be doing any converting, just like the center of the Earth doesn't need to be doing any converting of helium into anything or for hydrogen into anything. It doesn't need to be creating any atomic structures or making gold or doing anything to be melted, okay, to be hot, very hot. So hot that it melts almost 3/4 of the Earth is molten, or it might be a little more than that. So it's obviously creating a lot of heat, okay, and it's not doing any alchemy. It's not doing any transitioning. It's not creating atoms. All right. So the sun doesn't need to create atoms to produce heat. So the idea that we can make energy by smashing hydrogens together, I'd argue the illogical part of it is that you need a lot of pressure to do that. It requires pressure. And the trick isn't that, like the simple trick I've pointed out that, look, physics could have known this, way, hundreds of years ago. Back in they could have known this as soon as Gauss and Maxwell gave them a diagram of charge. That, obviously, if you have 2 protons, I don't need a strong force to get them to stick together. I don't need to do work to push them together. All I have to do is stick an electron in here, quite obviously. Now, why they didn't think, well, I have this problem. How do I push these things? I got to invent a strong force. I don't need any strong force. I put an electron between them. They will get very, very close as the width of the electron. They'll get really close to each other. And then if I happen to hit this electron with enough force, I can pop it right out of there. And they'll have 2 protons that are really close to each other, and they're going to create, because every bit of green force going in is going to be turned into red force facing each other. So you could sort of understand that the 2 protons are going to be sitting there, and there's going to be a ton of force created from the green force here and the green force coming this way, all of it's going to be converted into red, and all that red's going to bounce back and forth, pushing the objects away from each other at very high velocities. So that's the energy we're after. We're after the the fusion. Fusion is in, fission, they're saying is out. Okay. Yeah, well, anyway, we're after the fission. We're after, let's break things. Let's not, to get energy out. You have to get energy out by releasing the pressure that has been created. Now, a little subtlety to this argument is, it'd be nice if you just said, okay, you could just sneak an electron in here gracefully, okay, and the protons will come in and you don't have to use much pressure, and so you could create the very close protons without using much energy, and then you could release them by knocking the electron out and gain all of that energy. But the catch is that it's a really noisy universe, and when you have a proton and an electron getting close to each other, the problem is there's a bunch of forces hitting them this way and this way, and those forces, those torques, keep stopping them from being able to get close to each other. So what you need the high pressure for is to force them close enough to each other where the bond gets really, really indestructible. That is, the attraction between them is so strong that even torque forces hitting them at these different angles won't break them apart. So without an incredible force differential shearing them apart, they don't want to come apart. You need pressure to create that circumstance. And the truth is in 8 minutes or something like that, if I take that neutron and I put it out in space, it'll fall apart because the torque forces will just start ripping it a little bit further apart, and it'll be stuck in some hydrogen state where it just can't, the bits aren't going to get away from each other, but they can't get as close to each other as they can get when they're in the form of a neutron inside a pressurized vessel, which is any dense planet, very pressurized. But I would argue it has to be high enough pressure, the pressure of a sun, to start making the neutrons. And that's what the sun is doing. It's making neutrons. And the fact is it can't really get colder, right? So the whole idea, they have this idea that suns are using their energy, and they can't really do that. They can't use their energy up because their energy is basically being created by the gravitational mass. So they have to at some point excrete their mass to be able to lose their energy. And that's probably in the life cycle of suns are periods where it explodes, the surface explodes off and it loses its surface. And that's how it becomes a dwarf. Or that's how it becomes a dead or colder star, is that it has to excrete, a lot of matter. And reduce its gravity, and therefore reduce the amount of pressure and the heat and all of that. So the very idea of this chasing fusion and cold fusion, it's sort of idiotic because the truth is you have to use a lot of energy to create the high pressure to try to create the neutrons, and that's really what you're going to be building. Are neutrons, and then the neutrons again create this very nice circumstance, where you have this phenomenon, proton, electron, proton, and that's the thing you take advantage of. That's the thing you break and create all of this extra energy. That's the nuclear bomb. The nuclear bomb is this happening. And the truth is it's a little more complicated in the sense that obviously inside the atom there might be another electron here, electron, proton, electron, proton. You knock out this one, then you free one of the neutrons. One of the neutrons goes flying off and the other proton goes flying off. So you're gaining a neutron and a proton when you knock out the one electron. And that's more likely to be what's happening in, say, uranium, because it's creating the extra neutrons that fly into another atom and knock out an electron, and free another neutron. So every time the neutron hits the atom and knocks an electron out, or a proton, either way it works, it's still a neutron that'll fly out. Knock out this proton, these two electrons will repel each other and do the same thing. And that's what you're really doing. And that's what you can make energy doing. But you're not going to make energy making neutrons, because you won't be able to collect as much energy as it took you to smash them all together. You're just not going to come out profiting. So the easy profit is breaking existing atoms. So figuring out how to break other atoms besides uranium, to find some other nucleus. They probably all have a vulnerability. All the whole periodic table is full of a bunch of different compounds, and there's probably little tricks you can do for certain ones to disrupt their nucleus. They probably have a vulnerability. So it's kind of like Luke Skywalker and the Death Star. The Death Star is this powerful thing, blah, 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 blah. No, but it has this little, it has this little anal fissure, where, yes, you drop a grenade in just the right place and the whole thing blows up. Well, there's probably, for all of these other compounds, some little trick that causes their atoms to fissure and break, their nucleuses, and to take advantage of the high pressure you can create by knocking electrons, just out of place. I would speculate. So they, I think, have wasted a lot of money trying to pursue this hydrogen-helium thing, and to me, that's a waste of time, because those are atoms that can't have much energy in them because they're the elemental ones. And the ones you really want to play with are the heavy, atoms, because there's lots of energy in them, because there's lots of neutrons to separate from the atom. And every time you separate a neutron, you're going to get that neutron with a lot of energy. You're going to need a very good catcher's glove to catch it, because it's going to have a lot of energy. So, so I think that's probably most of what I wanted to cover. So it's really just wrong when they say the reason why the sun is hot and that it's radiating all this radiant heat in the form of photons and other bits of crap, is because it's changing hydrogen into helium. That's not why it's hot. It's hot because it's really massive, and it's under the center of the sun is under extreme pressure, and it's creating neutrons. It's turning hydrogen into neutrons, and that's why it's hot. That's not even why it's hot. It's hot because it's under a high pressure, and everything is being forced to do things it doesn't want to do, and all of those energies, the energy going this way and the energy going this way, the energy going this way, the energy going this way, all of the energy directed in all of these directions can't cancel. That's the key point. None of it can cancel. There's no canceling energy. You always have to say it has to go somewhere. So you either free it, or you stop it from banging into itself and you free it, or you're stuck with it banging in, and it just keeps doing this, and then this, and then this. It keeps jiggling, all right, until you liberate it back to the universe to go about its voyaging. So it's not canceling, it's antagonizing. It's caught in a trap, and that's it. So the trap can be circular, or the trap can be back and forth. That's the trap, though. Whenever you trap energy, it's still going to be moving in your trap. You can't cancel it out of existence. No such thing as positive and negative energy. No such thing as, subtractable energy. There's no such thing as unenergy or anti-energy. There's just motion in the universe, and all of it counts. And all of it's real, and all of it has to continue to go somewhere. None of it can just stop somewhere and stay there forever. All right, that's probably enough of a speech. So anyway, So you've got all of these elemental things wrong. It's not waves, it's particles. Momentum is everything, mass times velocity. There's no velocity squared. It's not even a rational concept. A cube of velocity is a nonsensical geometric object. It's a real absolute three-dimensional physical universe. Things have to travel time and distance and all of that kind of crap, and you can't evade any of those rules. There's no wormholes or any of this other bullshit. There's certainly no entanglement, and there's no superpositions, and all of that shit is completely unnecessary. It's just little bits of force that have momentum. They're quantized, so they all have the same elemental Planck energy, and all you can do is hit something in different ways. You can hit resonant to their oscillation, like microwaves hit water, and because the water will vibrate at the same frequency as the energy you're introduced, or one of the resonant frequencies, the energy goes into the water and just keeps increasing its energy, because you're adding it and maintaining the oscillation. You're keeping it alive. How else to say that? That's just the tipping point argument. It's just that simple. So when Einstein analyzed photons, he sits there and says, "Oh, it has more energy." No, it doesn't have any more energy. Blue light doesn't have more energy. It's just that blue light hits things while they're still moving in the direction the light is coming from. Red light is too slow. It hits, and then the thing moves back the other way, and then it hits, and the thing moves back the other way, and the thing hits, and it moves back the other way. So it's just about a tipping point, not about more energy in any absolute sense. It's about how you deliver the energy. You deliver energy fast, you will break things. You can break this glass by just tapping it really quickly. And it won't be able to absorb the energy. It won't be able to pass the energy through the whole object. And so this part will be fractured because you've broken it. Just like you can break sound. You can break air by going faster than the speed of sound. So if you go faster than the air can transmit the sound, then this whole structure, the atoms, will start to bang into each other and pressurize and create a mess. A mess that'll actually be sound. That's the irony. Sound, is always something moving faster than the medium can adjust to it. Faster than the medium can flex to it. If the medium flexes to it, it diminishes to nothing. If the medium can't flex to it, then it just keeps going. Get it? All right. Elementally, this physics is not that complicated, and the resistance to even looking at the better explanation than all the woo and nonsense is pretty surprising. That intelligent people can't recognize that, the elemental universe should be elemental, and questions like, well, how do you make an elemental pull? Oh, that's right, you can't. Okay, so let's give up on even imagining something that silly, and realize that if something looks like it's being pulled, you just look around the other side and see where it's being pushed, okay? And then you'll understand why it's moving. And, that argument alone is so simple and so obvious that, yes, come on. If there is a universe and it's doing something, it's doing push. It isn't doing pull. It's not a PUSHaverse. God. It does surprise me just how dumb the people pretending to be smart are. And it's a sad frickin' truth. It's very tragic and sad how you've wasted millions of years, hundreds of millions of years of evolution to create a brain, tens of thousands of years of struggle and hardship to acquire knowledge. Men had to be burned up in space capsules, all kinds of, people did all kinds of things and got killed in all kinds of ways for us to gain knowledge, and here you are just being obnoxious to facts. just obnoxious. You don't want to hear them. You're very poor representatives of a very expensive commodity called intelligence.